Hello, this is Techtedder with another science snippet. In today's science snippet, we're going to talk about states of matter and how they change. There are three main states of matter. One is a solid, one is a liquid, and the last is a gas. Solids hold their shape and have a fixed or set volume. Liquids take the shape of the container they're in and have a fixed volume. Gases take the shape of the container they're in, but they also take the volume. So let's look at those definitions a little closer. First we have solid. Solid is an object that has its own volume and shape. And if you notice these molecules, they're packed very closely and tight together. This is a solid. Liquids are a substance that has its own volume but must take the shape of the container it is in. Notice these molecules are spread a little more far apart. If I were to pour out these molecules, they would take the shape of whatever else I put them in. Whether it's a table, they take the shape of the table, or a pitcher. Gas is our last of the three states of matter that we're going to look at, and it's a substance that has no definitive shape or volume. Oftentimes gas is invisible. Here are some great examples of solids. First we have a brick, which we know is solid because we can push on it and touch it and it's not going to move. It takes a lot of strength to break a brick. All same goes for these weights made out of steel or some type of metal. They're very sturdy and very strong. But if I let them go or pour them out of a container, they're going to stay exactly like they are. They aren't going to change shape. Same goes for this guitar, this stump of wood, and this item that's in this petri dish. Yes, as you can see, it isn't a dish, but it doesn't take the shape of that dish. It keeps its same rectangular shape. Here are some examples of liquids. If you notice, this liquid is being poured out into a pan, and it's starting to spread out or blob out. It's going to eventually spread out enough to take the shape of the pan and fill in like this. It's not going to go past the edge because there's a lip or something to contain it into that space. Water is a great example of a liquid. You can see here we don't see the container, but we know that it's a liquid because of the way it looks. The ocean, or the sea, this is a sea actually in Jamaica, takes the shape of the land, or the area of the land around it. So it is a liquid. Now this one's a little tricky. Would you say that this set of objects is completely a liquid? If you said no, you're exactly right. If you notice, in these glasses are some ice cubes. The ice cubes are solid, while the actual liquid in the glass is the liquid. So these are not completely liquids. They're only partly liquids. And here's an example of some gases. In a hot air balloon, a substance is heated to cause the air to push up against the pressure of the balloon to make it rise. These balloons are filled with some type of gas to make them rise. Most often, helium is one of the substances used to fill them. If you notice down here, we're having something called evaporation occur. When the water from a lake or other source of water collection is heated up enough by the sun, pretend this is our sun here, it evaporates or causes the water to start to form steam. You see it here because it's in transition, but if you move up to here, you stop seeing the actual gas. And the same happens if we add heat to our water on the stove. You start to see steam form off the stove. This is a good indication that you are creating a gas. Changes in states of matter. We're going to look at physical change. Physical change is a change in an object's state of matter. In some way, I can get the object back from its original state. Now, you're probably thinking, what do I mean by that? This is a great example of a physical change. A broken pencil. I broke my pencil in half. If I simply put the pencil back together, I'll have the original pencil and its pieces back together. I could always glue or tape it to make it stay. Next we have a broken plate or dish. The same goes for this. I can put the pieces back together and still have what I started out with. I still have a plate, it's just broken into pieces. Heating and cooling of certain objects or solids makes things change from state to state. So anytime I heat something that's solid, it's going to melt. And anytime I freeze something that's a liquid or cool it off, we are freezing it. And if I want to go from here to the gas, we are boiling. And if I want to go from gas to solid, we're again adding that cold temperature, or we're condensating, or condensating over here to get back to liquid. And there's another term from gas straight to solid. We're not going to take a look at that today. We're going to only look at physical changes versus chemical changes in the 3 states of matter. See this ice cream here? Let's say you were walking down the street and dropped your ice cream cone. And it's really hot outside, so it started to melt. This is a physical change. I could actually take my ice cream cone and put it back in the freezer, and it would freeze again and be cold and ready to eat. This piece of ice is laid out on a table in a very hot room. As you can see, it's starting to form water at the bottom because it's melting. And melting is a physical change. Melting is a physical change. Now, there's a certain thing I want you to look at this egg. I don't want you to look at this egg as a boiled egg. I want you to look at it as an egg that's been cut up into pieces. And if we look at it that way, then we can say it's a physical change. Our egg still has the same 2 parts. We've just cut it into different pieces. So yes, this is a physical change. Now this one looks a little tricky. If crayons, and the crayons are melted, and then they have plain old crayon wax left over. If you let crayons get hot enough, they will melt. So we have our melting. Then if you let them sit for a while, they do harden back up or freeze. And it doesn't even have to be cold, just as long as there's a change in the temperature. What's cold to us isn't always cold to everyone else. So they can then freeze again back into the shape that they were melted from. Will they ever go back as crayons? Well, yes, if we put them in some type of mold to mold them back into the shape of a crayon. But they're not going to go back unless we mold them. But right now they still are going through a physical change. And cutting. Cutting is a great and wonderful example of physical change. Anytime I cut something, of course, I can always put the pieces back together to complete the physical change. Melting, freezing, boiling, cutting, chopping, tearing, things like that are great examples of physical change. So physical change versus chemical change. Now here's where things get a little tricky. Physical change, I'm changing an object, but I'm not changing what it's made of. I can cut this wood into pieces, but I'll still have 2 pieces of wood. But if I burn the wood and create a chemical change, I won't have any wood left. I'll have what we call ashes left. I can never take those ashes and turn them back into a log. So remember that chemical change creates a new substance. So let's see how you do. Would you say this is a chemical change or physical change? Now again, don't look at the egg as being cut, but look at the egg as being cooked. That's right, this is a chemical change, so it does not fit into our physical change category. I cannot take my egg and put it back in the eggshell and create an egg in that way or shape or form. It's always going to be changed once I add the heat to it. Fireworks are another great example of a chemical change, which means they won't be physical. I cannot take the pieces of a firework once they're burned and put them back together. All we have are ashes. Popcorn's another wonderful example of chemical change, but it's not physical change. Definitely not physical change, because with popcorn, you know how you get little kernels of popcorn? Once I add heat to the kernels of popcorn, it pops and it changes. Are you noticing a trend in this? Are you noticing that when I add heat to things, they make a different change? Sounds interesting. Wonder what that means. A burning match is kind of like a burning piece of wood. It's going to be a chemical change. I cannot get that piece of wood back. Baking is another wonderful example of chemical change. It's definitely not a physical change, because once I bake a cookie, unless I break apart the cookie, I can't pull apart the eggs, the flour, the baking powder, and the chocolate chips. The only thing I'm going to get out when I break up the cookie is the chocolate chips. So it is not a physical change, it is chemical change. Again, it is not a physical change, it is a chemical change, because I can't get back the ingredients I put in. This apple has been cut, so that would have been a physical change, except now this side has been exposed to the air and started a process called rotting, or it's been oxygenated when the air hits the parts of the apple. So this apple has started to make a chemical change. I cannot change it back to this at any time. To get this, we'd have to cut off the slice of apple and throw that piece away. And this is one of my favorite examples of chemical change. It's a nail. Bikes do this. Any type of metal outside oxidates or they rust at some time in their lifespan. This nail has oxidated and we can never get back its shiny new appearance. If we do, it's because we scraped off the rust, but that part that we scraped off has forever changed that part of the nail. This has been a Techtedders Science Snippet. Thanks for joining.